Rust tutorial number 3. Variables, types, and functions. These are the building blocks of every Rust program. Let us learn how they work. In Rust, variables are immutable by default. You cannot change them after creation. This is the opposite of most languages. In Kotlin, val is immutable. In Rust, plain let is immutable. To make a variable changeable, add the mut keyword. Let mut count equals 0 allows you to modify count later. Only add mut when you actually need to change the value. For values fixed at compile time, use constant. Constants must have a type annotation, are always immutable, and use screaming snake case by convention. They cannot be computed at runtime. Rust has many integer types. I32 is the default, assigned 32-bit integer. Use U for unsigned, I for signed. The number is the bit size. U size is special, it matches your platform pointer size. Floating point numbers default to F64, which is more precise than F32 and nearly as fast on modern CPUs. Booleans are true or false. Characters use single quotes and support full Unicode. Strings in Rust have two types. String slice, written &str, is borrowed and fixed size. Capital S string is owned, heap allocated, and growable. This distinction matters for ownership. Use &str for function parameters and string literals. Use capital S string when you need to build or modify text. The format macro creates a string. Println prints directly to the terminal. Tuples group multiple values of different types. Access elements by index with .0, .1, or use destructuring to unpack them into separate variables. Tuples are useful for returning multiple values. Arrays have a fixed size known at compile time. All elements must be the same type. For growable lists, use vec instead. Array syntax uses square brackets with the type and size separated by a semicolon. Rust has powerful type inference. It figures out types without you writing them. Let x equals 42 infers I32. Let pi equals 3.14 infers F64. Add explicit types only when the compiler asks. Shadowing lets you declare a new variable with the same name. Each let creates a new variable. The old one is dropped. Unlike mutation, shadowing can even change the type of the variable. Shadowing is useful for data conversion. Read input as a string, then shadow it by parsing to an integer. Same name, different type. With mut, you cannot change types, only values. Functions in Rust use the fn keyword. Parameters must have type annotations. The basic syntax is fn name, open parenthesis, parameter colon type, close parenthesis, then the body and curly braces. Functions return values using the last expression without a semicolon. This is important. Adding a semicolon changes the return type to unit, which is like void. The compiler will catch this mistake. Use the return keyword for early exits from a function. For the final return value, just write the expression without a semicolon. Both styles work, but the no semicolon style is more idiomatic Rust. In Rust, almost everything is an expression that returns a value. If else is an expression. Blocks are expressions. You can assign the result of an if statement directly to a variable. Rust does not do implicit type conversion. You must use as for casting between numeric types, parse for string to number, and to string for number to string. The compiler forces you to be explicit. Common mistakes include forgetting mut when you need to change a variable, passing a string literal where a capital S string is expected, and adding a semicolon to the return expression of a function. In the next video, we tackle ownership. This is the most important concept in Rust, and the reason it does not need a garbage collector. Once you understand ownership, everything else clicks into place.